Okay, so I'm going to test the motherboard, make sure that it's functional. I thought also I put the video so you guys also have some idea how to assemble the board. So first thing you do, you install the step sticks. So these are motor drivers, and the orientation is that you put the potentiometer facing the right side. So this little circle is the potentiometer. With turning the potentiometer clockwise, you will increase the current to the motors. With counterclockwise, you decrease the current. And if the motors on the printer are quite noisy, they make a lot of noise, that means there's too much current going to the motors. So we turn them counterclockwise to decrease the current. And if during the print you see that it's misses steps, so the motors don't have enough power to turn, to move the nozzle around, and you turn them clockwise and it will increase the current. So once they are installed, I'm going to install the power. So the middle two are ground, the upper pin is VCC, which is 24 volts, and the lower is 5 volts. Now I don't use a 5 volt because I get the power from the USB to serial, but in case you wanted to put the 5 volts there, you can just connect it between the middle pin and the 5 volt, so which is this guy. Okay, then I'm connecting the fan. So the red wire of the fan connects to the upper pin, then there's a ground, then I'm just testing the first extruder, so it says extruder 1, and then fan, just to make sure that it operates. And then this is for the second extruder. So extruder 1, extruder 2, extruder 3, and this is extruder 4. Once that is installed, it's also like this is a Z-axis. This goes for when the printer is facing you, you connect the left motor, and this connects the right motor. So when printer facing you, the right motor connects to this socket. And then extruder 0, 1, 2, and 3. 4 extruders total. So these are the end stop pins. And I'm also testing the end stops, make sure that they work. The longer end stop is for the x-axis and connects to EMX, M lowercase, because right beside it is EMX. It works, but in the software I didn't use it, and you don't really use it in the hardware as well, but perhaps for future. And so this is the X micro switch. Then goes the Y micro switch. It's blue wire, and it's the shorter wire. It goes to EMY with M lowercase. So when you connect dopant, so these connectors are called dopant connector, and when it goes, you should feel some resistance when you push it in. If it's too loose when it goes there, it means something wrong with the dopant wire. It may not be connected. And for the Z-axis, we have 3 wires, unlike 2 wires. And I'll also show you how to connect that. So I got the wire, this guy. So this is a sensor for the Z-axis. It's optical. I'll explain the benefit later. And let me see if I could focus here. there. Okay, so the first pin is VCC, and as a standard I use blue as the VCC. So talking the colors on the wire, not the dopant connector wire. So you have blue, you have brown and purple. Purple is signal. So the video was disconnected, my phone ran out of memory. So this is the optical sensor. The VCC is blue, wire goes like this. Da-da-da. Okay, so the colors is look at these colors. So blue is VCC, brown is ground, and purple is the signal. This pin is extra, it's analog output that we don't use it. Everything's digital here. So on the other side, the blue wire VCC, it goes on the EMZ M lowercase top pin. Then the brown goes to EMZ M capital lower pin, and the purple goes to EMZ M lowercase lower pin. So this is how it goes. So this is the VCC blue pin, this is ground, and this is the signal pin, which is purple. So now I have the optical and the stop setup as well. Then you want to install the temperature sensors. So there is a sensor with a paper clip, looks like this, and the two end goes to the they go to the first position of temperatures. I'll bring it up in a sec to show it to you guys. And the regular temperature sensors, which I have two for two extruders. So go to the sockets. This is labeled with S2 and S3. So the first one. Still like to go in. And the second temperature sensor was in here. Like this. Alright, and then we want to install the SD card reader. So there's one extra pin here. It's because the extra pin here is 3.3 volts that feeds the SD card reader, but this card already has a built-in 3.35 to 3.3 volt converter. So the pin alignment, so the pin, the extra socket on the right side, you just don't use it. and this socket, the first one, you don't connect it. Leave it open. So that's connected. There's a Wi-Fi module. It's a famous ESP 8266. It's connected there. And lastly, we put the USB to serial module. On the USB to serial module, I have 2 pins. Okay, that's a little clear now. So the DTR pin and 3.3 volt pin, I cut them. You have to cut it too, especially the DTR. If it's there, the microcontroller won't turn on. It is because in their design, at least the board that I have for USB to serial, the DTR is resetting the microcontroller on the board USB to serial, and it's not the real DTR pin on the serial port. So you just don't connect it. So on the back looks like this, and this pin is extra. I said 3.3 volt, but it's not used anymore because I already put the 3.3 regulator down here. Now one thing important is that the Wi-Fi module will not work unless you have the SD card installed. So if you're trying to run the module, the Wi-Fi, and then the microcontroller keeps resetting, you need to install the SD card module first. Okay, so all set. Now I'm going to go to the front interface, which I have right here, and it's COM8, baud rate is 115/200. Know if it's clear enough. I do connect, so connected to the board, and you can see the temperatures. The bed is 26, the extruder is 25, so that's tool 1. And if you go to tool 0, that's extruder 0, which is 24. And if something's wrong with the temperature sensors, you read like 0 temperature or like crazy high values that shows some wire is not connected. Then turn on the power, and I just test it. See if the module works. It's gonna connect. It doesn't work for some reason. Alright. And I forgot to install the motors. I thought something doesn't work. Well, you gotta connect the motors so that it could spin. Turn it on, and so X motors, and go reverse. It's good. Y axis, it turn the other way. So one more time, couple more times. So go together and go together. Okay, and the Z axis, I always test both directions, make sure that driver is good, and then X home, and to stop it you need to push the hit switch, so X axis, Y axis. And one thing that you should notice is that it moves a little fast, and then once it's hit, it will move the other direction slower. So goes, hits it, moves slower, and release. So when the head goes and hits the push button, it will actually move back to release the push button, so no tension is there. And Z axis as well. So this is the Z axis. and it works. So XYZ works, 3-axis works. The temperature, just check they work, and I'm going to test the fan. So this is the main fan, and then you can run it if you type M106, enter, and M107 will stop the fan. Okay, so the fan is good, and then test the extruder one. Look at the LED here, kind of turns on. I put too much resist over value. It's hard to get it on, but it works. And I switch the tool to 1, I test it again, set it, so it turns on. That's the second LED. Turns off, turns on, turns off. In order to read the data in the SD card, just over here real quick, you have to initiate. So initiate the SD card using M21 command, and then M20 will read the content of the SD card. So that shows the SD module works, and I'm going to also test the solid state drives. So there are 2 solid state drives, 1 and 2, and just connected them to a lamp, because I needed something with 110 volts. To make sure that it kind of works. So the first guy goes in. The first 2 pin is for the 24 volt power supply. So it turns on and off the main power to the motors and to the extruders. Alright, and then I plug this in. The power cord, so it's right here. Then I have a lamp. So any move command that I initiate should turn on the lamp. Just give it a... Okay, it doesn't work. What did I not connect? Connect this, I connect this, and I connect this. Okay, apparently I have a faulty part here, so let's just test the other guy just to make sure. Oh yeah, okay, that wasn't completely in, I guess. One more time. Nope. Off. So okay, I'm going to pause the video, see if I'm doing something wrong, and then I'll be back. Alright, so I look at the problem. I found the problem. One of the pins on the Terrayoc driver was not soldered, so I fixed that. And now if I have the lamp here, and I just issue any command, well, lamp turn on and turn off. So this is for the power supply. Just apply the power, and the next 2 is for the heated bed. I already tested it, so I know it works. And in order to test the Wi-Fi, so you have to use a pin header. And as I mentioned earlier, the Wi-Fi module works only if the SD card is installed. So if I go and connect this right now, Oh, before I connect it, the Wi-Fi module takes a lot more current, so just the USB is not enough, and that's why I use the external power supply that you also got it. It's a 1 amp 110 to USB cord. So you connect this, and it gives you the extra 1 amp that you need in order to run the Wi-Fi module. Let me just install that. Alright, and this pin, 2 pin, goes between pin 2 and 3 on the board. Alright, you just get it there first, and then I explain what I did. Alright, so zooming over. So what you can see here, I got the 3 pin, the pin 1 and 2 the jumper has to go there. So it gives 3.3 volts to the Wi-Fi module. If you use pin 3 and 2, connect them together, apply 5 volts to the Wi-Fi module, likely you will burn it. So make sure that you use pin 1 and 2 as a jumper, and then in order to test that it works, if I give it AT commands, that should respond. Now AT commands is not compatible with front interface, so it is going to give me an error. That's why I will close this. I'll go to the Arduino, make sure that you set up the right COM port. Just COM8, connect here. You get the COM port, make sure you have both NL and CR, and then to test it, send a command such as M114. I will reply back the position of the nozzle or the head. Okay, next command is G101. So G101 creates a direct bridge between the serial port and the Wi-Fi module. Now whatever you type here, I will go to the board. So if you type in 80, you're expected to receive a response OK. Also, if you disconnect the pin and connect it back again, AI Tinker Technology Ltd ready, 80, and it will respond back OK. So the Wi-Fi module is there, it's good too. And that's about it. So I'll do this for every board to make sure that when I ship the printers, the board that you get is already tested and is functional. The reason is, well, we assemble these boards here in Ontario, and sometimes something could go wrong. So thanks for watching.